Hey everyone. In this video, I want to go over how to find a confidence interval for a sample proportion. So in this case, we have a one-tailed test, and so we are going to, if it's a 99% confidence interval, we want to make sure the extra 1% is all to one side because it's one-tailed. In this case, since our initial claim was that we're less than a certain value, we want to make sure that we have an upper bound because we're looking for less than a certain value. So we're going to look for the upper bound for this particular confidence interval, and that's all we care about is the upper bound. So to find the upper bound, I'm going to use the norm inverse function. And since I want the whole 1% to be on that upper tail, I'm going to use 0.99 as my probability. My mean is going to be p hat, and my standard deviation is going to be the standard error for this problem. So that gives me an upper bound of 24. So anything less than 24.31% is inside my confidence interval. So in this case, the original claim was 20%, and 20% is inside my confidence interval, so I would fail to reject the null hypothesis. So in the other video, I've already worked through this confidence interval, so you can look at that. For this last problem, where our claim is that it's more than 55%, to create our confidence interval, again, it's going to be a 95% confidence interval. That goes along with a 0.05 significance level. But we want all 5% of that to be on the lower half, the lower tail. So we're going to find the lower bound, and to do that, we're going to use norm inverse, but we're going to put all 5% at the bottom. Our mean is p hat, our standard deviation is the standard error, and that gives us 56, anything greater than 56.03%. Now, our original claim of 55% is outside of this confidence interval, which is why we rejected the null hypothesis to begin with. I hope this clarifies any misunderstandings you might have had, and I'm sure they were due to stuff that I've taught you in the past. All right, I'll see you in the next one.